Hello. Today we're going to be talking about a related rate type problem where we have a ladder sliding down the wall. So it would be a wall and then a ladder sliding down the wall. And we know that it's sliding down the wall in a downward direction at 0.15 meters per second. And we want to know what is the length of this ladder, knowing that at 3 feet or 3 meters away from the wall, the speed at which it's moving away is 0.2 meters per second. So first I want to draw a picture of what's going on. So here is my wall. Okay. And I'm going to have this as my ladder. Okay. And so the ladder, we have that. I'm going to call this my x, which is the distance away from the wall. And we know that we have a downward motion of 0.15 meters per second. We have a downward motion. So what we should recognize from this picture is that I have a right triangle. So right triangles results in Pythagorean's theorem, or at least tells me that I should use Pythagorean's theorem. So this can be redrawn as a right triangle. I'm going to call this x, I'm going to call this y, and I'm going to call this z. I could call it d or abc, but I'll use these variables. Well, since this is a right triangle, I know by Pythagorean's theorem that this is x squared plus y squared equals z squared. And so here is my formula that I will use for, or at least this is my equation that I will use for this related rate type problem. So now that I have an equation, I want to find the change in time, or take the derivative with respect to time to the left and right of this equation. So let me rewrite the equation here. Let's use this color. So this is going to be x squared, or so d dt of x squared plus y squared equals d dt of z squared. Now, in order to take the derivative with respect to both sides, that means I am implicitly differentiating both sides of the equation with respect to t. So remember, when I take the derivative of x squared with respect to t, that's going to be a chain rule. So that's going to be a result of 2x dx dt plus 2y dy dt equals 2z dz dt. Okay. Now, this is a related rate. It's related to this type of problem. Now, one thing to keep in mind is that x is the direction away, pushing away from the wall. Y is the direction going down the wall. And z is just this ladder. Now, how much is changing with the length of the ladder? Well, we'd like to assume that there's no change in that, or we know that there is no change in the length of the ladder. It's not like a collapsible ladder or anything. So there's no change in the ladder, so that means our equation is in fact 2x dx dt plus 2y dy dt equals 0. Okay. Now, in the word problem, it says the speed of dx dt, or the change in x, is when x equals 3 is going to be 0.2. And we know that the ladder is constantly decreasing in velocity, it's got a downward velocity of 0.15 meters per second. So what this means to say is we know dy dt equals negative 0.15. It's negative because it's going in the downwards direction. We know dx dt equals 0.2, and it's positive because it's moving in the positive direction when x equals, and that's going to be when x equals 3. So there's a question. What's y? Okay, what does y equal? Because if I know what y equals, I already know what x equals. I don't know what y equals. I ultimately want to know what is z. So I have an equation here with 1, 2, 3, 4 variables. I know 1, 2, 3 variables values. I am missing the y value. So from here, I'm going to solve for y. So let's just start that process. So again, I know 2x dx dt plus 2y dy dt equals 0. I want to solve for y. So that's what I'm going to do. I'm going to solve for y here. So I'm going to bring everything to the right. So that's going to be 2y dy dt equals negative 2x dx dt. Okay. I'm going to divide by 2 dy dt to both sides. And I ultimately get y equals negative 2x dx dt divide, oh, sorry, I don't want my 2's anymore. Because the 2's will cancel. So that's going to be negative x dx dt divided by y dy dt. Okay. And so that is my y. I know what x is. X is going to be 3. My dx dt is 0.2. My y is not there. There shouldn't be a y here. My dy dt is negative 0.15. So I do this calculation, I'm going to get 4. When I calculate this out, I get 4. So now I know, going back to the original problem, I know x equals 3. I now know y equals 4. Solving for z, we have z equals the square root of x squared plus y squared. Okay? Given that x equals 3 and y equals 4, that's the square root of 3 squared plus 4 squared. And you may have already noticed that this is a 3, 4, 5 triangle, which equals the square root of 9 plus 16, which equals the square root of 25, which then equals 5. So the length of this ladder is 5 meters.